we know that the standard form of the equation of a circle is this. Remember its relation to the Pythagorean theorem. So we'll put in 8 for h, -6 for k, and 2 for r. Remember the difference between the sign, the operation that you see in the parentheses versus the sign of the x and y coordinates. Simplify the 2 squared as 4. To put it in general form, you can FOIL this out or use the special formula for squaring a binomial. We have to put the squared terms first in the XY order. Then the terms to the first in the XY order. And sorry about that. That should be a plus because that was a +6. 64 plus 36 is 100. And that is equal to the 4 here. So subtract the 4 from both sides. To get it equal to 0. Real quick, I'm checking something in my head. Yes, okay. Now I'm going to go with the, you could go with either version here. You may find some things, pros and cons to either. To find our x-intercepts, put in 0 for y, which in the standard form, 0 plus 6 is 6, 6 squared is 36. And I'm going to isolate the part that has x in only one place, even though it's squared, subtract 36 from both sides, and I see that there can be no solutions to that because no real number squared is going to give us a negative. So no x-intercepts. Actually, I knew this was going to happen, and it's going to be the same for the y-intercepts. When I put in 0 for x, 0 minus 8 is -8. -8 squared is +64. And when we subtract 64, we get -60. No solutions, so none for the y-intercepts either. And momentarily it'll become hopefully a little bit clearer why this had to be the case. Now, symmetries, if you put in -x or -y, that's not going to help. Whether you do one at a time or both, since you could factor out a negative and then square it, that's going to give you the quantity x plus 8 squared. There's no way in general to get that to be the same as x minus 8 quantity squared. It might be true for maybe 2 values of x perhaps, maybe 4, but if there was going to be y-axis symmetry, then changing x to negative x, we would need this to be for all points on the circle. And so similarly, for the y plus 6 that we had up here, factor out a -1, square the -1, you're still left with this quantity squared. So no way are you going to get that for every xy ordered pair on the graph of the circle. Would you get the quantity y minus 6 squared versus the quantity y minus 6, y minus and y plus 6, those quantities squared for every xy ordered pair on the graph of the circle? It's not going to happen. There are, however, symmetries that this circle has. Since I couldn't find any intercepts, I'm going to plug in some value for either x or y. Now, let me first show you this. We've got a center at 8, -6 with a radius of 2. So if I go up 2, I'd be at 8, -4. If I go left 2 of the center, I'd be at 6, -6. If I go right 2, I'd be at 10, -6. And if I go down 2, I'd be at 8, -8. Mistype that. See if I can fix that. 8, -8. All right, let's move this around. So the point A, the way it's listed here, is our center. And now you can see why I knew that we were not going to get x or y intercepts. Now, I'm going to pick something for x that is between the 6 and the 10. Let's go with 7. So I'll plug it into the standard form. And that was equal to 4. 7 minus 8 is -1, but -1 squared is 1. And I will subtract 1 from both sides. Take the square root. Including the plus minus there. This is actually going to give me 2 points. And although on that website that I was just showing you, I'm going to be able to type it in exactly. -6 minus square root of 3 is giving me approximately -7.7. So I put in 7 for x, and I'm getting -7.7. I'm also getting for y, when I plug in 7 for x, -6 plus the square root of 3 to the nearest tenth, that is -4.3. Okay, so 7 plus, comma, -6 plus or minus square root of 3. 7, -6 minus the square root of 3. And you can see that that is at approximately -7.7. It's just a little bit above the -8 that we had for the coordinate f. And when I switched the addition, so -7, comma, -6 plus square root of 3. Oh, that was supposed to be +7. Then that is supposed to be about -4.3. Sure looks like it. And that should give you enough detail to draw your circle. Remember on your online homework system that you're going to want to make sure that when you click on a point, you have the coordinates you're going for one thing, that it's matching up exactly with what you've calculated. Also, let's see here. I claimed that there would be some symmetry if we have a horizontal line segment going through the center. The center was the 8, -6. So if you see a part of the line y equals -6, then you have G as a reflection of F there. You could keep that going. Also reflect both of those over the vertical line segment connecting B and E there. So you could reflect F over here and G over here. Now, those are diameters. They are not points on the circle. So I'm going to do something real quick here. To see those as dashed lines, if I can. Yep, we sure can. See if that shows up. I got it for the first one, but not the second one. Yeah, sort of there. Okay, on to one more example.